Good afternoon, students. Welcome back to science class on the chapter force. Uh, Today, I give the notes for law of conservation of momentum derivation. Okay. So in the previous class, we discussed it, right? When we say that the momentum is conserved, and also we proved that one mathematically. Okay. If the initial momentum is equal to final momentum, then we can say that momentum is conserved. Okay. So today I give the notes. So, yeah. First, consider a body. Consider a body A. Consider a body A of mass m1 moving m1 moving with the velocity moving with the velocity moving moving with the moving with the velocity moving with the velocity u1 collide with another body collide with another body B B of mass m2 B of mass m2 moving in the same direction with a velocity u2 with the velocity u2. Let t be the time interval. Let t be the time of impact. Time of impact. Then draw this diagram. Okay. Object B moving with initial velocities u1 and u2, and this is before collision. Before collision. Before collision. Before collision. This is during collision. Okay, A, B, and B. Here, object A, it applies a force on B, and object B, it applies force on A. So I will take that force as FA and FB. Okay, here object A, it applies force on B and B on A. Okay, but see here, both the forces are opposite direction. Both the forces are in opposite direction. Okay, now this is during collision. During collision. After collision, what happens? Once again, both will separate, right? A, B. So at that time, velocity changes. So I'll take its velocity, object A, its velocity changes to V1, and object B, its velocity changes to V2. Okay, this is after collision. After collision. Okay, after collision. Before collision, during collision, and after collision. V1, V2, be the V1 and V2 be the velocities of the bodies A and B respectively. A and B respectively. A and B respectively. Okay. Respectively. After. Okay. So then the force exerted by the body A. Then the force exerted. Then the force exerted by the body A, then the force exerted by the body A on the body B, on the body B is okay, is, that is FA is equals to force. So we know the formula, that is F is equals to mass into acceleration. Okay, so here object A, see that object A which exerts force on the B. So that's why here we should take FA, force is equals to mass of B into acceleration of B. Mass of B into acceleration of B. Acceleration of B. So what is the mass of B? So we have considered, right, mass of B as m2 into what is the acceleration? So the acceleration means what? Change in velocity. So here that object B, we changed its velocity from u1 u2 to v2. Okay, that is v2 minus u2 in our time t. So we can write this as m2 into V2 minus U2 divided by T. Here, next one. Yeah, no need to write this one. You can write directly this one also. Okay, no problem. Write directly M2 equal to V2 minus U2. Next, this is all right. What the force? The force exerted by the force exerted by body B on body A. Okay, the force exerted by the body B, the force exerted by the body B on the force exerted by the body B on the body A, on the body A is, that is, FB is equals to mass of A into acceleration of A, acceleration of A, mass of A into acceleration of A, that is FB is equals to M U1 divided by T. Why? Because the of that body A, so it has to change it from U1 to V1, right? So that's why change velocity, that is V1 minus U1 divided by, call this equation as 2. So what's the next step? You know, right, from Newton's third law of motion, to every action there is equal and opposite reaction. Okay, so here both the forces are equal. Why? Because the force A, the body A which exerts the force on B, so that's why that the body B also exerts the force on body A. Okay, so both the forces are equal, but they are in opposite direction. What is that? But they are in opposite direction. Okay. Now, so yeah, so we can say that here both the objects will collide, right? A and B. So this is FA and FB. So I will take this force as action and this force as reaction. Okay, here that body exerts force on body B, that is action. So you know, right, to every action there is an opposite and equal reaction. Correct? For example, say I will apply force on the wall. Correct? So this is the action. Even this board also applies exerts force on my head. That is the reaction. Action and reaction are same, but they are in opposite direction. Okay? Yes. Right. Next one. FA. FA equal to M2 into V2 minus U2 divided by time T. Okay, so this is equation 1, and FB M1 V1 minus U1 divided by T. This equation has 2. So both are equal, but they are in opposite direction, right? Okay. So don't write here, no need to write separately. Already you have written, right? So now here I have written here. Okay? See here. Next. FA can be regarded as action. FA can be regarded as action action while FB as the reaction. FB as the reaction from Newton's third law, from Newton's third law. These two are equal. These two are equal and opposite. These two are equal and opposite. Okay, so that is FA is equals to minus FB. Here that minus sign, what it indicates? It indicates that force is in the opposite direction. Okay, that force is in opposite direction. So now substitute the values. What is FA is equals to M2 V2 minus U2 divided by T. Then minus what that is M1 into V1 minus U1 divided by T. Okay, so T get cancel, right? It cancel. So then T get cancel. Then M2 into V2 minus U2 is equals to minus M1 into V1 minus U1. Now so multiply M2 here, right? M1 here. Okay, so M2 into V2 minus M2 into U2 is equals to minus M1 V1 minus and minus plus, that is M1 U1. So now take M2 to that side and minus M1 this side. So that is M2 V2 plus M1 V1 is equals to M2 U2 plus M1 U1. Okay, M1 U1. Or finally we can write M1 V1 plus M2 V2 is equals to M1 U1 plus M2 U2. That is total initial momentum is equal to total final momentum, right? This one, total final momentum is equals to total initial momentum. Okay. So this is the principle of conservation of momentum. So clear? Momentum. See here, A, B, M1, This is before collision, during collision, after collision. Okay, V1, V2. What is the total moment, total initial momentum? That is M1, U1, U2, M1. See, total initial momentum, that is M1, U1 plus M2, U2. Clear? So which is equal to final momentum, that is M1 V1 plus M2 V2. Okay. See, we proved the same equation right here. Okay. So when do you say that momentum is conserved? When initial momentum is equal to the final momentum, then we can say that momentum is conserved. Okay. Yes. So now using this formula, now we can solve some problems. A bullet of mass 20 gram is horizontally fired is horizontally fired with the velocity 150 meter per second from a pistol. From a pistol of mass 2 kg. So what is the recoil velocity of the pistol? The recoil velocity of the pistol. Okay. Here, a bullet of mass 20 gram is horizontally fired with the velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? Recoil velocity already right. When you fire, okay, when that bullet leaves that gun, that gun it will come back, right? So we call that as recoil velocity. Okay. So now we are considering two objects, means that is bullet and pistol. Okay. So now first calculate total momentum before collision. Before collision means what? Before firing. Okay. Then calculate final momentum, that is total momentum after fire. Okay. So I will take mass of the bullet as m1, that is 20 gram. First convert into kilogram. That is how to convert? Just divide by, see, 1 kg is equals to 1000 gram, right? Then what about 20 gram? So 20 divided by 1000. So you will get 0.02 kg. Okay, 0.02 kg. So mass m1 is equals to 0.0, that is 0 meter per second. So we need V2. V2 means what? That is recoil velocity. Okay. Yes. What is the first? We know the formula. Initial momentum is equals to final momentum. Correct. So initial momentum is equals to final momentum. That is before collision and after collision. Okay. What is the initial momentum? M1 U1 plus M2 U2, which is equal to M1 V1 plus M2 V2. Clear? Okay. So first calculate initial momentum. I will calculate here. That is M1 U1 plus M2 U2. What is M1? M1 value, M1 is 0.02 into 0, initial velocity 0. Then what is M2? That is 2 kg. And what is U2? U2 is also 0. Okay. So then you will get to 0, 0 plus 0. So totally 0. So final moment, initial momentum is 0. Next calculate final momentum. That is M1 V1 plus M2 V2. Okay, so M1 is 0.02 into 150 plus M2 is 2. We don't know, right? Our work is to calculate V2. Okay. So what is the answer? 0.02 into 150. 0.0 150, that is 3, right? So 0.0 into 3 plus 2 V2. Okay, so this is the final momentum. Substitute here. That is 3 plus 2 V2. Okay, 2 V2. Now bring 3 this side. That is minus 3, right? So minus 3 is equals to 2 V2. Here 0 minus 3 will get answer 0 only. So then minus 3 divided by 2 is equals to V2. Okay. So then we can write that as, we'll write here. So V2 is equals to minus 3 divided by 2. Minus 3 divided by 2. So what is the answer there? That is V2 is equals to minus 1.5 meter per second. Here we got a minus, right? So it's that minus here, this minus sign which indicates what? That see, bullet is moving in this direction, that gun, that pistol is moving in this direction, right? So it is in opposite direction. Okay, so here that minus indicates that that pistol is moving in the opposite direction, because bullet is moving in this direction, then pistol is moving in this direction. So clear? Now see here. See, when is the momentum considered? Initial momentum is equals to final momentum, right? So you got initial momentum is equals to 0. Clear? See, we got initial momentum is equals to 0. So if you want to check that one, now see here, you got V2 equal to 1.5, right? So now just substitute here. Just substitute here and check it. See, initial momentum we got 0, right? So now I will substitute here V2 value. Okay? See here, no need to do this one. You can stop here. Here we need recoil rate. Recoil, that is V2 is equals to minus 1.5 meter per second. Enough. So now just to cross verify, just to check whether initial momentum equal to final momentum, or whether you have done this one, the problem whether it is correct or right. You can check yourself. See, initial momentum is 0. According to that condition, we should get to final momentum also 0, right? So now just substitute V2 value. What is V2? Minus 1.5. So that is 3 plus 2 into 1.5 minus 1.5. When you multiply 2 into minus 3 into 2 into minus 1, you will get 3 minus 3. So initial momentum is 0, right? So 3 minus 3, that is 0. So finally you will get final momentum 0, right? So both are equal, right? 0 equal to 0. Clear? Yes. Okay. Stop here. Tomorrow I'll continue the class. Thank you.